I've actually connected the two blacks of the meter leads together. This is on the negative rail, this on the positive rail. So this is without the current limiter in now, okay. Let's see what happens now. Well, we have about 14 volts on both, so the voltage is okay. And the protect light went out. That's interesting. Go again. Protect light is on. Protect light is off. You don't suppose, do you, that this thing should draw that amount of current anyway in its quiescent state, and that the whole thing we've been chasing is a red herring caused by me having the current limiter in the circuit? What do you think? Well, the only way we can really prove that would be to connect a audio source, stick some music into it. We'll connect a speaker to where the woofer, the tweeter connections are. The woofer was supposed to be working. I mean, we can connect to both actually, I guess, if we solder some wires on. And let's see if this thing actually, for all that hassle, which could be very educational, actually is working. I've now connected my speakers. These are full range speakers. They are actually jukebox speakers. Nothing amazing. I have some better ones, perhaps I should bring them in actually. So this is the woofer plus, we can see on here, woofer plus, and then tweeter plus is this brown wire. I had a three-way plug that just happens to fit on here. We can see that woofer minus and tweeter minus are actually connected together anyway, and they both go to the point here, yeah, ground. So what I've actually done is I've just connected the negative end of both speakers to ground, and then this is the woofer and this is the tweeter. So I have two full range speakers. One should get the bass, one should get the treble, but if we can hear the tweeter running, we know that's okay. I think I only have one speaker working. Yeah, I've only got sound coming out of this speaker, and this is the one that's connected to the woofer out on here. Go again. No output. Okay, switch it off. Plug this one back in. Switch it on. Okay, so we definitely do have a fault on this. If we look at this LM3886T, this is the power amplifier chip for the tweeter. The datasheet says that this is the inverting input and this is the non-inverting input. So this is like an op amp, a power op amp really. The output, we can have a look. So here we have tweeter plus, and that goes to there. So this is the output, okay, and then the other end of the tweeter goes to ground, okay. So when the signal is idle, this output should have basically 0 volts on it. Now, if we look at the inverting input, it comes down here. So we have a resistor, okay, 393. That's 39 and 3 zeros, so 39,000 or 39k. And that goes to another resistor here, which is 102. 10 and 2 more zeros is 1k. And the other end of the 39K goes off this way. And if we have a look, that goes to the output. So this is your standard feedback loop for an op amp. So the output via resistor to the inverting input. And then we'd assume, if that is the case, that this end of the 1K resistor would go to ground. Maybe directly, maybe not, but let's have a look. So from here to... okay, not directly. So it looks like this is your negative feedback circuit, 2 resistors which set the gain for the amplifier. Okay, and then this non-inverting input, this is the actual input to the amplifier. I'm not sure exactly where it goes to. Yeah, that comes down here through another resistor. That looks like a capacitor. So this is kind of like a capacitor between the feedback and the input signal by the looks of it. This then goes. Does it go down to one of these op amps? I mean, it may go via a resistor. That sounds like a diode junction I hit there. Just try resistance mode, see if I can find like a standard resistance value. So these are the outputs. So that's mega ohms. Mega ohms. I'm expecting less than that. Mega ohms. So it doesn't look like it goes to this one. Oh. 22K. So you might go here. Doesn't appear to go to this op amp. Okay. The output of these ones is on pins 5 and 12. It could come to this one. Let's have a quick look. So pin 5 is here. 53K. 9, 10, 11, 12 is there. And that's high. So it possibly goes down to one of these. I've just had a look under the board. It looks like that comes from here. Okay. To a capacitor. That is not an output on that chip. That is one of the inputs. So it's a little bit hard to trace where that goes to. I mean, if I put some effort in, I probably could find out. But I'm not sure I really need to know that right at this moment in time. We have 3 op amps down here that look very much like they're involved in this amplifier, okay? And we know where the outputs are on each of the chips. Now, with no signal coming in, you would expect, I would think, that the outputs would be kind of like 0 or near to 0 with no signal. We can have a look. So I'm just going to have a look. I mean, obviously this one is connected back to here. This is connected back to here. So I'm interested to see what's on them. I'm just going to have a look at all the outputs. So there's 4 there, and 2 there. So that's 10. And let's just see what voltages we have around these op amps in circuit, okay? This might tell us something. Whether it tells us something that makes any sense to us is another matter, but I'm sure it will tell us something. So we'll power this up. Protect light is out. Do I have any DC offset on the inputs? This is the first thing. So the inverting input is at 0, you'd expect that. Non-inverting it, yeah, 0. What we've got here, so 0, 0, 0, 0, okay. This is one of the power So the meter is working. We do have power on our chip. Okay. This is the other power. Yeah, plus and minus supply. This one, 0, 0, 0, and the other one goes to here, 0. And then it was pins 5 and 12. So 1, 2, 3, 4, 5 is here. Basically 0 and 16, 15, 14, 12 is here. Has a minus 13 on it. Okay. So apart from that one, all the rest is 0. I'm not sure if we can really read anything into that minus 13. Maybe we can if we look at around that chip. Let's have a quick look. If the output is at minus 12 volts here, then we'd expect the non-inverting input to be lower than the inverting input on 13 and 14. Let's have a look. Pin 13 is here, minus 12, and pin 14 goes here. So the non-inverting input on 14 is lower than the inverting input on 13. Yeah, so you would expect the output to go to the negative rail, so that's okay. I think that's just something on the board. I'll just clean it off. Yeah, it's nothing bad. Okay, so that op amp is in the situation it would be given those inputs. So I don't see anything particularly obvious there either. Let me stick some audio signal in now and have a look again on the outputs of these op amps. So it's switched off at the moment. I've now connected my signal generator. And you can see I have a 2 kilohertz signal there. It's about 1.2 volts to peak. I'll just make it a bit smaller actually. I'll just turn the amplitude down a little bit on my SigGen. It's about 800 millivolts now, okay? Now I'm going to go to the input on the LM3886 and just switch this on and see what we get here. So protect light on, off. And we don't have anything. Actually, we might remember it's like an op amp. You probably wouldn't see much signal there. We think that comes from down here. No. We do have signal going in. What's happening on the woofer out? We have a big output on that one. I don't want to have too much output on that woofer out, although there's no speaker. I'll just go up frequency a bit. Maybe it'll stop it putting so much output on that one. 5 kilohertz. Let's have another look again. So there's the incoming signal. Woofer out. What we got? Yeah, a lot smaller now. It's not amplifying that so much. Okay, tweeter out. Nothing. Nothing there. Let's look around these op amps again. We have a signal there. Signal there. So this one has a signal on 3 of the 4 outputs. Okay, this one, signal, signal, nothing on that one. That has a signal on 2 of the 4. And this one, it's pin 12 and 5. Let's have a look. So pin 5, which is actually here. We have a signal there. And 12, 9, 10, 11, 12, which is here. That's the one with the big negative voltage on it. Okay. So that's what I actually have. Okay guys, different day, same problem. Yeah. So the main thing I think with this is so far I haven't managed to pin down where the problem is. We know we have effectively with a sine wave coming in, we can see sine waves around these various chips. I'm wondering actually, now I didn't test it, if that is the one that's driving that. It could be actually. But basically I need to pin this down a bit closer. So the first thing I want to know really now is, does this chip that I changed work? I could reconnect the speakers. The other option, I'll just use my scope to save me getting all the wires out. And what I can do is I can inject a signal into here. So to do this, I've connected this wire to my signal generator. I've set it to 5 kilohertz sine wave. I've soldered a capacitor onto here. This is a 10 nanofarad. So I'm just going to put the signal in via the capacitor. That's to stop any DC level that might be on here getting into this chip. So we can just put the signal by touching that. I've attached my oscilloscope probe. So this is to the tweeter out, and then ground for both the oscilloscope and the signal generator is here onto the ground lead. We know that's ground. I could otherwise have just reconnected the speakers, but I think this was just a bit quicker. They'll both, I would think, do the same thing. So if I switch this on and put a signal onto here, I want to see if anything comes out of the tweeter out on the oscilloscope. If we're using a speaker, we would just listen for the sound. Okay, you can see the protect light, which has now gone out. So just watch on the scope and see what happens. Well, there, straight away, yeah. You can see that's all I need to do. I don't need to do any more than that. I know full well if I put a signal into this, the amplifier actually works. So the problem then is definitely further back. I have at least a couple of options now. One is to really sit down and trace this signal back to see where it comes from, and then inject the signal further back, or see if I find something wrong. But if there's like an open circuit resistor or a faulty capacitor in this system or something, I might not easily spot it. The other option is to unsolder these op amps, the 6 of them, and test them in an external op amp tester. At least if I know they are good, I will have eliminated that. And I think this is kind of like 6 of one and half a dozen of the other as to which is the best bet. Back in the day when I was working on industrial electronics repair, we would probably just test all the chips we could, and anything we couldn't test we would just change. I've ordered some of these 2060s anyway, they're not here. I don't think I have that 13700. I might actually have one of those. And I don't think I have these. Let me have a quick look. Okay, I do have the LM13700. As I mentioned, these two I've already ordered. I don't have the 4560 in this package. I do have the 393 in this package. So I have some of the parts here. I think let's go down the line of testing the op amps first. If we test all of the chips and we know they are good, and we know that is good, then the only thing left is something in between, which is basically here, resistors and capacitors. And this is my homemade tester. I actually made a video on this. I'll see if I can find it and link it into the description of this one. And I'm pretty sure I could build a quad op amp tester on here, but basically this one I'll just show you. So this is that BA4560. And you can see it flashes the LEDs backwards and forwards. And this is the LM358. Actually, that one doesn't. That one does, so that actually was a Duff one I had there. So we actually see the tester in action here. Duff. So we'll use this one, I think. Now to do this, I have a little breakout board here. I think this will fit into the socket. Yeah, it will fit into the socket. This actually has an op amp on. I think I was using this to test something before. Let's just plug it in. Yeah, that's lighting both up. I'm not sure what that chip actually was. That's an LM393, that one. Actually, I have the polarity wrong, you see. Pin 1 up here, so I wonder if I've damaged that. Let's have a look. Looks like if it was working before, it isn't now. So I can use this little board to solder my chip on. Well, I've got them off, and I had a problem with this, and I've had this problem with especially mixer PCBs. These chips are glued down, and by the time you get the glue to melt to come off, you tend to singe the board or even delaminate it like this. You see this area here? Now, this is a double-sided PCB. There's no internal layers on these, so generally speaking, you can get away with it, or you can soon figure out if you've caused any problems, because like these vias just go through the board and you can measure them. This is looking a little bit suspect as well, so that really didn't go very well. The third one again, you see where the glue was. So this is very hard resin. If you guys know any better way of doing that, let me know, because this causes me problems. But as I say, because these boards are just double-sided, it isn't usually an issue. I mean, I have a bit of a issue with that component there. Let's just measure that. So there's a 22k resistor across it. Looks like a capacitor to me. And it reads 22k, so either the capacitor's open or it's fine. Yeah. Capacitors tend to go short if they fail. Let's also have a look at this. So we have, oh, this pad here. This is power. Yeah, this is the plus 14 volt supply. So I can soon figure out if I've got power on there or not. That goes through the board, as you can see there. I can see where that goes, it's here. Well, if I put my meter leads either side of it, I've got continuity. But from the pad I actually haven't, so that via is given up. I can drop a wire through there, it's not a massive issue, it's unfortunate, but with this type of glue I'm not really sure any other way you can do this better. Let's just have a look. Yeah, I can shine the light through there so you can see what's happened, but I can easily get a wire through and just solder it to the pad and solder it to wherever it goes. The other side, that isn't too much of a issue. Okay, just unfortunate. Let's have a look to see if these chips are any good. So this is one of them. You can see the glue. This is the problem, okay? So this is 4560. It may well have been damaged because I had to get so much heat into it. There's that one, but we can test it. Here is the other one. Seems to have come off a little bit better. Again, you can see all the glue underneath it. Okay. And the other one, the 393. Okay. Yeah, glued. Right, let's try them. Okay, here's the first one. Yep, soldered on the right way round. We can clearly see where pin 1 is. Yeah. In fact, you can even see pin 4 here actually goes to pin 4 on the chip. Okay. Let's try this one. So we'll put the power on. We'll just push this onto here. And that chip is okay. Okay, here goes the next one. Power on. Get it the right way round. Chips the right way round. Okay. That one is not okay. So one of the 2 op amps in there is okay, and the other one is not. Yeah. So that's bad. And then let's try the 393 as well. So this is a bad one. This one's a bit difficult to say which way round it goes. I've soldered it on, but I'm not sure if there's actually like a little dot there. I think the best way with this one is going to be just to see if we can figure out which way it was on the board. I've got the recording from the video, and then we'll know which is the positive supply. We should be able to work out which way around it goes. Yes, I'm just looking at my recording now. This end of it is where it says 393.
Yeah.
I think you can see that clearly. Yeah. So this is where it says 393, and this is pin 8, pin 1. I know that because if I measure from this point to the push supply on one of these, I get a continuity. So this is the positive supply rail. So if we just check again, I know this is correct. Just showing you guys. This is where it said 393 at this end, okay. There. And this is where the 12 volts is just here. This is where the wire is broken, so I don't actually see it here, by the way, but I see it there. Say plus 12, it's plus 14 actually. So we know that's the plus 14, no problem. So the chip's the right way round. Let's test it. Power on. So pin 1 up here. And that isn't working either, but I'm not totally sure this actually will test the comparators rather than op amps. I don't think it actually does test them. I can probably prove that actually. Yeah, here's another LM393, okay. Yeah, and it doesn't test those. I may as well change the 393 anyway because I have to order the 456zeros. So I'll change it anyway, but I think it's probably okay. So it looks like we have one faulty 4560, which would very much explain the problem we had. I'll replace all of them because they've had some heat stress basically. Now the other thing I just want to check before we finish this one, and we'll talk about something as well. So given the problems I had desoldering these and the fact I found a definite fault, although it could have happened when I unsoldered it, but for one side to fail seems a bit odd and the other one tested okay. I don't honestly know which one came from here and which one came from here, but they've had a fair bit of heat on both. I don't want to unsolder these because I'm going to have the same problem I had here, and it may well be unnecessary. As I say, we found a definite fault here. Now we know we've caused one problem here. We may have caused another one with this capacitor. While we're here without the chips, I'm just going to test all the resistors in this area as well, just to see A, if they've been damaged because of the heat, and B, if anything reads strange. So 153, that's 15 and 3 zeros, 15k, reads just about that. 10k reads just about 10k. Bear in mind they may read lower than they should. So 221, 22 and 10, 220 ohm. Yeah, exactly. 10k. Pretty close. 1k, 102. 153, that's a 15k again. Reads right. Another 1k. Yeah, looking good. 2.2k. Yep. Another 220 ohm. Looks okay. Now we're in the area where I got a lot of heat in here. This is this suspicious looking cap, but we know it tests okay, but at least across this resistor. 22k. 33k, yeah. Another 1k, another 33, another 1. So these all look okay. Then we have some 0 ohm resistors here. Read 0, read 0. 1 meg, 105, 10 and 5 more zeros. Reads open. That reads 40. 3.3k. Reads close. 100k. Reads very close, really. Another one, 1 meg. So that reads a lot lower, but we're probably reading something else across the resistor. The only way to test that would be to remove it And you'll notice these are all held on with glue as well again. Another 1 meg. Reading low again. In fact, these both read, are they in parallel with each other? No, they're not in parallel. I was thinking because they both read about half, maybe they're in parallel, but they're not. Okay, another one. That reads open again. But this again is where we had quite a lot of heat. The board is delaminated slightly here. But being double-sided, it's not really a problem. Okay, that one reads open. That reads lower. 1K. Yeah. Another one of these 1 meg. That one's actually reading, no, it's going lower now, like a capacitor's charging. Probably this big capacitor, that's what's charging. This one. 100K, yeah, it reads 50. Another one. Reads 50. These in parallel. No. 220K. It's often the high value ones that will read strange because there's other things across them. So you can't really say. 2.2K. $2.2K. What else do we have? 560 ohm. Okay. 560 ohm. Yeah. 5.6K. Close. 2.2. Another 2.2. Another 560 ohm. 27K. Yeah, close. Well, close enough because it's in circuit. 5.6K, 5.7. That reads slightly higher, but I think that's pretty much intolerance. 47K, yeah. Another one. Oh, here's another one of these 1 meg. And that one reads okay, so it's not my meter having any problem reading 1 meg resistors, okay? And a 10K. Right, so what we have, we need to replace these 1 meg resistors. I have no idea if they've failed due to the heat, if there's something peculiar about high value resistors that will fail due to the heat. They're all glued on, which is not helpful. Some of them have lower readings, which may have something across them, or they may actually be faulty. I'm just reading there's something else. I can't trust any of those 1 megs apart from the one that reads correctly. Yeah. We need to fix this via here, but we know about that, and we have possibly a suspicious capacitor there. And all these components are going to be glued down, so I don't want to be taking them off and testing them if I really can avoid doing that. Therefore, I'll replace the chips. I'll put new ones. We have one faulty anyway, we know that. This stuff will arrive, but I don't want to mess with them. I just want to change that and see if it fixes the problem. And the same with these 1 meg resistors. I'm going to have to, I'll change all of the 1 meg resistors. I don't trust any of them. These transistors, I'm going to leave them as they are for now, and we're going to try this again with the new chips on and see if it will work. I'm kind of 50-50 a bit on this one. The nature of the fault on one op amp would explain the type of problem we have. So in that respect, there's a good chance. The 50-50 comes about because these glued on components were so hard to desolder that I may have damaged it during the desoldering, and there's no way to prove that, guys. Of course, let me know what you think. Yeah. Most important, does anybody know how to work on these things with these soldered on chips without causing more damage than you started off with? Yeah. Okay. Let us know. And if you don't, let me know if you enjoyed this video anyway. Okay. Look forward to seeing you all again soon on Learning Electronics Repair. Ciao for now, guys.